Welcome to the section Scaling ElasticSearch. In this section, we're going to take a look at how ElasticSearch can easily scale across different nodes. There are some things we need to look at, though, for how our data is organized. We've been talking about indexes a lot throughout this whole series. What we haven't touched on is how data is stored within those indexes. Data is stored in shards and what a replica shard is. After that, we'll look at scaling our cluster horizontally. We'll add ElasticSearch nodes. Then we'll talk about the different types of nodes. Starting with a master node, we'll make a dedicated master node. And then we'll look at how we can make some nodes master eligible, how to have data-specific nodes as well as index-specific nodes. Then we'll look at some cloud offerings for ElasticSearch. We'll build some resiliency using AWS as well as Elastic's offering. In this video, we're going to talk about indexes, shards, and replicas. Throughout this video, we're going to figure out why it took us so long to talk about this, scaling ElasticSearch. That's one of the biggest features that you get when you use ElasticSearch. We'll talk about a shard and what it is. We'll talk about replica shards and how we can plan our shard distribution across an ElasticSearch cluster. All right, to start with, what is a shard? So a shard is one of the basic constructs of ElasticSearch. This is where data is actually stored. It's a Lucene index. Lucene is the full-text search engine that ElasticSearch uses. It's basically the de facto standard Java framework for full-text indexing. We'll look at how we can use shards throughout this series for scaling our ElasticSearch cluster and our being able to index and search a lot faster. So this is all about performance and distribution. So let's start at the beginning. We've talked about indexes a lot. So if you think about the indexes we've built for daily rolling logs or for an application performance, or as well as just application use in general for fast access to data, index is where data is stored or organized. Within an index, though, it's actually broken up on disk into multiple shards if you follow a multi-shard configuration. By default, indexes have 5 shards. So if you think about that data we put in for the metric beats, every day there are 5 Lucene indexes made in our cluster that store the active data for that index. So this is where you put in data, you query data, you get it back out. This is a distributed storage feature. It's also good because now if these shards are distributed in a horizontal cluster, you've now distributed the processing of that data as well as searching of that data. So it's distributed indexing. You can have 5 computers or servers processing this data as it's being indexed to be stored. You can have 5 nodes also doing a search at the same time. You think about distributed search, and then you have a master or a primary node that then consolidates all of those search results into one result set. And it's also a good way to split up data. So if you get 100 gigabytes of data a day, it doesn't all land on the same computer, the same server. It can be shared across a bunch of different ones. And you'll see in the picture we have a replica shard as well. We'll get into those more later, but that's kind of your backup. So you start with your 5 shards, and then each shard gets a replica if that's how you have your index configured, and that's really your safety. So these replicas, they definitely protect you against the failure of a node. So imagine you have a 3-node ElasticSearch cluster, and your indexes are distributed and they're backed up using replicas across your cluster, and one of your nodes goes down. So now you've got that redundancy built in. So you no longer have to rely on, you don't have one single point of failure for that data. If that one server goes down, like all of our examples so far have been a one ElasticSearch node, that's really bad. So in a real-world production environment, you're going to have multiple nodes in your cluster. And so we've got this redundancy built in for the data. You want to protect your data and make sure that it doesn't get lost for a system failure or hardware failure. Another big benefit now is the enhanced search speed. This is for the primary shards, but you can also search against replicas for increased speed. All right, so we've talked about this failure a little bit, and I'm going to show you what our node looks like for now. But when we think about distributing these shards across our ElasticSearch cluster that we're going to build throughout this series, we want to talk about how many nodes you would build in your production or your development environment. If you have one node and one node fails, oh, you're kind of screwed. If you have 5 nodes and one node fails and your data is distributed properly, then no big deal. You'll just kind of lose some performance for a little bit of time. Everything will rebalance and the cluster will be happy. So you got to figure out, and there's no magic bullet on this one. This is a really hard task to handle when figuring out your cluster. And really it is. There's some formulas Elastic will give you on how large to make your cluster, how large to make your indexes and your shards, but you got to really figure this out for your data and your application. So if we talk about distributing Elasticsearch, in AWS, for instance, you have multiple data centers. You have multiple availability zones. Where do you want to put your data and where do you want your data backed up? If you put it all in, one data center at AWS and God forbid something happens to that data center, then you've lost all your data. But if you have one data center, 2 data centers in a region, for instance, the US East region, we can have multiple data centers there, so you can distribute across those data centers. Well, depending on your data and your criticality of your application, do you need to have that data across multiple availability zones? Do you need one in the US East and one in the US West? There's a lot of implications there, so this is one thing you have to figure out for your data. You've got network transport data or network transport costs to figure out, data storage costs. The more replications you have, the more disk you're going to need. But the bigger your cluster is, the wider your cluster is, the more globally distributed your cluster is, then you can handle more failovers. So that's always what you need to figure out. It's that how much do I want to provision to handle different types of failovers. So let's look at our cluster right now, and I'm going to show you visually what these indexes and shards look like for the data we've been building so far. So I'm jumping over to Kibana, and going through the menu, I'll pick the monitoring tab on the left, and we can already see here, I've kind of skipped over this, but if we can look at our Elasticsearch cluster, the health is yellow. What that means is it's living, it's working, you haven't lost any data, but it hasn't been able to distribute your shards, your replica shards, as you've configured. So let me show you an index. So here we can see we have 45 primary shards. That's the primary shards for all of our indexes. We don't have any replica shards, so nothing is being replicated. So I clicked on the Indexes tab, and let's look here. We can see they're all in a yellow status. They all have 5 unassigned shards. So let's pick a metric beat from 2018, March 25th. So if we click on here, then we can see that we have 5 unassigned shards. We only have one node, and that is holding our 5 primary shards. So these unassigned shards, you can see, are unassigned replica shards. So we'll talk about that as we add nodes to this cluster.